So, yeah, so the next speaker is again from online. And are you ready now?
Yes.
Okay, and okay, so the next speaker is Seyed, Habib, Hosseini, Saravani, et al.
Yes.
Okay, and they are going to talk about the title is Are language models capable of detecting the topoi in argumentative statements? Okay. Okay, whenever you're ready, please.
Okay. Thank you so much. Hello, my name is Seyed Habib Hosseini Saravani. Thank you for joining this meeting and this presentation, and I also thank conference organizers for providing this atmosphere. I'm a PhD student at the Department of Linguistics at the University of Quebec in Montreal, and my research area is natural language processing and computational linguistics. Okay, in this presentation, we're going to, which is actually kind of interdisciplinary research. We are going to answer two main questions. The first question is, can language models detect the topoi in argumentative statements? And the other question is, are the topoi at hand, the topoi that exists in the data related to the lexical meaning of linguistic expressions? To understand more about the topoi, I'm going to have a kind of overview on a term which is called anthememe. Actually, in argumentation, there must be at least one premise and a target conclusion. Like an example, I show you here. Here we have one major premise and a minor premise and the conclusion. And this is a usual type of argumentation. So the example is either the package will arrive today or it will arrive tomorrow. And the minor premise is the package did not arrive today. So the conclusion is the package will arrive tomorrow. But in another kind of argumentation, which is called on enthymeme, the shared common knowledge, which is usually one part of the premises, is not stated. It is somehow implicit. It's not explicit. Like the example here, this is an example. He must be a great pilot. He was in the Air Force. So in this argumentative statement, something is hidden, something is not stated, and that thing is members of the Air Force are typically well trained in flying. So this is considered as a kind of common knowledge. So it is not stated, and this is the what we can call a topos, and this makes this kind of argumentation different from usual kind of argumentation in which everything is stated. So this is another example from a paper, and give the delivery person a tip. They carried the box all the way inside. So here, the topos is hard work deserves reward. So we can say that somehow give the delivery person a tip because hard work deserves a reward, or hard work deserves a reward. They carried the box all the way inside, therefore give the delivery person a tip, but this is not stated. So this is a kind of enthymeme, or we have a kind of topos here. So in general, the word topos is a kind of Greek word which means place, but in the context of dialectic and rhetoric, it has a technical meaning, which is, in English, it is conveyed by a Greek word topos, and sometimes by the term topic. Topos, if we can say that topos is somehow equal to topic, so topoi is the plural form of topos, which means topics somehow. Aristotle characterizes a topos as something under which many enthymemes fall. So, but about the second question we're going to answer in this research, in the argumentation within language, the theory of argumentation within language, usually linguistic expressions carry argumentative orientations and directions. So the topoi are assumed to be part of the lexical the meaning of or linguistic expressions. I have another example from another paper, which they say that claim quality and the existing lexicon in claims can affect the quality of argumentation, but it is debatable, especially from the perspective of logic. From a logical perspective, two utterances that convey the same information in the same situation have identical semantic effect. So in this research, we try to answer this question based on the results of our research. So first, we try to investigate if large language models are capable of detecting the topoi in argumentative statements. I'm going to give you a brief overview of language models. This is the kind of traditional language model. In traditional language models, usually the traditional language models want to give you a kind of probability of a word given the words or a word or a sequence of words that come before that word. For example, here, this calculation, which is a kind of conditional probability, wants to tell you or tell us what is the probability of the word going given the words where are we. So this is a kind of traditional language model. It is a kind of simplistic explanation, but the general idea is this. But transformer-based language models, which we use in this research, are much more complex. I mean, the calculations, mathematical calculations behind transformer-based language models are very complex, and they are able to process long sequences of words. Usually they work based on a kind of mechanism which is called attention mechanism or self-attention. And the well-known transformer-based models, language models are GPT, which is the model behind ChatGPT, and BERT and T5. The data we used in this research is ARCT, or maybe it can be called ARCT data set. It is designed for the argument reasoning comprehension task, and in this data set we have a claim, a premise, and a reason, and there are two. Here in this data set, instead of the word topoi, the term warrant is used. So in this data set, we have two warrants. One of them is true and the other one is not true. We are going to use this data set and train the language model to detect the correct warrant or the correct topoi. This is an example of existing in the data set. As you can see here, we have the claim, or we have the reason Miss America gives honors and education scholarships. And the claim is that Miss America is good for women. But we have two warrants, warrant 0 and warrant 1. Warrant 0 says that scholarships would give women a chance to study, which is here this is the correct, this is the correct label. The correct label is 0, which means that warrant 0 is correct. And warrant 1 says that the scholarship would take women from the home. And we have around 1,970 observations in that data set like this. So we use two kinds of models. The first one is called, or we use two kinds of approaches. The first one is a fine-tuning a Roberta language model, and the second approach is prompt engineering GPT-3 or GPT 3.5 language model. In fine-tuning, in general, fine-tuning is somehow using a pre-trained model, which is designed for a general purpose, and fine-tune that for specific, for a particular task. In fine-tuning process, usually the fine-tuning process that we did in this research, the inputs are somehow fed to the model, passed through the model, and then the pre-trained model layers generate contextualized representation of the input. And this is how we can use the pre-trained language model. And then after that, we can use that contextualized representations of the input in classification tasks. So what we do is a kind of binary classification to predict the correct warrants, as I explained before. And this is these are two examples of our inputs. So we concatenated the reason, the claim, and two warrants. I mean, two warrants, once the true and then the wrong warrant, and then we labeled the data like this. Miss America gives honors and education and scholarships. Miss America is good for women. Scholarships would give women a chance to study. We labeled it as 1, which means that this is in our research, label 1 means that this is a true input, I mean correct input. And then with the same reason and claim, we concatenated the second warrant, which is now the wrong one, and then we labeled it with 0. So these are our inputs, and then these are our labels. With this data, we are going to classify the data. In prompt engineering, usually prompt engineering is done every day by students and maybe professors too. So we give GPT 3.5 pre-trained language model a prompt, and we want to extract whatever we want from the model. So in this research, we wanted the language model to tell us which topos or which warrant is correct based on the information or the prompt we gave to the model. So this is an example. In the next slide, I will show you two examples. But again, we have two approaches here. The first approach is called zero-shot learning, and the second one is few-shot learning. In zero-shot learning, the prompt only describes the tasks. The task, we don't show the model an example, but in the few-shot learning, we also show the model some examples. So these are two examples. In zero-shot learning, we only ask the model, kindly review the provided reason, claim, warrant 0 and warrant 1 information in the question. Your task is to predict the warrant that best aligns with the logic, and logically supports the reason claim. Choose either warrant 0 or warrant 1 as your answer. So the model should generate an answer, and the answers can be only warrant 0 or warrant 1. And then we also said to the model that if you're uncertain, please select the option that appears most probable based on the extracted logic. So the model cannot say, I don't know, or neither of them, or both of them. The model is forced to choose between warrant 1 and warrant 0. But in future learning, we have a similar thing, but maybe with different wording. But we also show the model two examples. And the examples are, this is the claim and this is the reason, and this is the true warrant. And we showed the model two examples, which somehow helps the model to return the true answer. And so in the second part, we try to answer the question whether the topoi at hand are related to lexical meaning or the linguistic expressions. So to do that, we chose a methodology, an approach which maybe was not the best one, but due to the time limit, mostly because of time limit, we decided to automatically paraphrase the claims and the reasons using, again, a GPT-3 model. So these are two examples. This is an original data, and this is a paraphrase one. So Paul's results create a public narrative rather than reality. And the claim is that polling undermine democracy. And GPT-3 paraphrased it like this: the opinion of the public as indicated by polls is not necessarily reflective of the truth. And the claim is voting polls erode democratic principles. And as you can see here, the information in the paraphrased version is more. So our a statistical analysis showed that on average 24%, the paraphrased version was 24% longer than the original person, and only 27% of the words existing in original version existed only in the paraphrase. So it could somehow tell us that. So, however, or although it is not the best approach, but yeah, now we can somehow expect that the paraphrased version is different from the original one. So, and the results showed that the models showed in general moderate performance. The accuracy we received from our model for all of the models, a few shot prompt engineering, zero shot prompt engineering, and fine-tuned Roberta, the accuracy were around 70%. The best one was 71.5, and the F1 score, which is which somehow considers both the accuracy in both classes. Again, it was around 70, but the best one was 70. And after paraphrasing, again, the results before and after paraphrasing showed that paraphrasing did not affect the results. On the contrary, the results with a bit better, not that much, but a bit better, which maybe is because we have more information in paraphrase, which can help language models. And what we learned from this research were first moderate performance from language models to detect the topoi, which is good. And the next one is paraphrasing did not affect the results. So we can maybe claim that there was no direct relationship between the topoi at hand and the lexical meaning of linguistic expressions. But this doesn't mean that we're claiming that this is we're generalizing or maybe overgeneralizing that. Though the results suggest that the topoi at hand might not be strictly lexical, but it doesn't mean that this is true for all the topoi. And the limitations of this research is, I think, the kind of approach we chose for paraphrasing, because that was not because we didn't have much control over the choosing choosing which words are being replaced by other words and or phrases, and because there are some somehow counter examples, we know that excuse and justification, or the synonyms thrifty and miser, they are somehow they are used as synonyms, but uh, they somehow the topoi they can appear in are quite distinct. So this shows that for future we need to use better approaches for maybe paraphrasing, or maybe how we can handle these kind of challenging pairs as synonyms. Thank you very much for your attention.
Thank you very much. Now let's move on to the discussion. Do you have any? Okay, Erin, over there. Should I come to the front? Yeah, right. Yeah. So, please use this.
It's so complicated. Hi. Where's the cameras here? Here. It's such a difficult environment. No, so it's such a nice talk. Thank you so much. And very impressive that you stopped at the precise moment of the 20-minute mark. That was my question. My question was, what kind of paraphrasing method would do better?
Excuse me, I think your microphone is off.
Yeah. That's the one.
Okay, please talk to.
Is this better?
Oh, much better, thank you. Yeah.
Okay. So I had this microphone, which was not an actual microphone connected to you. So now, did you hear anything I said?
Yeah, you're talking about paraphrasing. Yeah.
Okay, good. So what I wondered is if you had any ideas as to what kind of paraphrasing method might do better for looking at these topoi of the like the ones you mentioned, thrifty and so on, and also sort of more so other candidates for sort of topoi that contain lexical content, for example, ideological topoi and things of this nature. Thanks.
Thank you for the question. Yeah, I understand the question. Yeah, as you mentioned, paraphrasing can done in different ways by replacing just some words, replacing them with their synonyms, or maybe more complex kind of paraphrasing, which changes different structures in the sentence. But I think that for at least for this research, we decided to only focus on actually this was what we thought would be the best approach, but unfortunately we didn't have much control on paraphrasing because of what I explained. We did it automatically, but we thought that the best approach, at least for the first step, is only replacing some important words in the warrants. For example, instead of let me just show you this example. This is for example, instead of maybe this one, sorry. Yeah. For example, instead of a scholarship, because scholarship can have kind of meaning behind itself. So instead of a scholarship, maybe if we replace it with the word funding, so what happens? Because a scholarship has a kind of different meaning. So the best approach we thought at the first step was just replacing only keywords in the warrants or the topoi, and maybe it can be considered as the best way to understand if there is a kind of relationship between the lexical meaning of some words, some keywords, and their argumentative and their argumentative meanings, or somehow, and the topoi. Or I hope that I understood your question correctly, but if yeah, thank you.
Thank you. And so, any other questions or comments?
Okay, now I know what to do.
Yeah, yeah. Hello, thank
Hello.
you very much. Okay, I think it was a very interesting talk.
Thank you.
I wanted to ask you something about the warrants. I have an intuition that there might be cases where with like at least two possible warrants for one topoi. At least this is what my intuition tells me. So this is the first case that I thought about. And the second case, it was actually about your example with the antimeme that you gave about the hard work. So I thought that there, in fact, so you said that the antimeme was that the hard work needs to be rewarded. Yes, thank you. So this, but also it might be the another antimeme here that in fact the fact that they carried the box all the way inside was hard work. But as human beings, we don't say that, right? Because we're intuitive about these things in language. So we kind of skip certain things, but it might be the case that in fact there are some hidden antimemes here as well, right? Because we tend
Exactly.
to be flexible with language, etc. So my question is about those two cases where in fact there might be, so in the first case it would be two antimemes in one warrant, right? Or here, let's say two antimemes in one argument. And the question is, how would the large language models deal with these things? What would you expect here? Would you expect that there will be some correlation between the let's say complexity or topoi complexity in this sense and the performance? I hope I'm clear with what I'm trying to ask.
Thank you for the question. Yeah, it was a really good question. But actually, we expect that when, yeah, as you mentioned, that was a very good point. Here, there is another kind of topoi which we can add here. That the topos can be carrying the box all the way inside is hard work. So if we do not consider it as hard work, so and then the rest of the scenario is canceled. So, but we consider that when language models can detect the topoi, they are capable of detecting the topoi. This is a kind of generalization somehow. So they can detect even the topoi we have not studied in this research, or the topoi that do not exist in the data set. So as I said, yeah, we are not somehow extracting all the topoi in the sentences in the data set. We are just giving the language model some samples, and we are just testing if they understand the correct topoi. But we expect that large language models can. So this research showed that their capability is moderate, but we cannot generalize it because we do not have a good data sets, or maybe a lot of data sets. So based on only this data set, we received moderate performance, and we expect that this moderate performance is general for all kind of topoi, because large language models are trained with tons of data, and the information is distributed in all that data, and because they can detect that distribution of information in the data set, because of some I'm going to just make it short because of time. So because of two things, large language models are capable of understanding the semantic and syntactic relationship between the linguistic structures. One of them is a kind of technique for representation of the data, which is called word embedding, and the other one is for transformer-based language models, the self-attention. And these two mechanisms enable large language models to detect the syntactic and semantic connections between the words and in general the structures in language. So my answer is we expect that large language models are also capable of detecting that hard work. Carrying boxes is hard work.
Okay, thank you very much.
Thank you.
Okay, thank you very much. So let's thank the speaker.